Today we're going to learn how to do stereopsis using the Frisby Stereotest, and this test helps us to measure stereopsis without the need for special glasses. And when we do this test in lab, we can use the 1.5 millimeter or the 3 millimeter test, but today we're going to use the 3 millimeter test for our purposes. And this test is useful to us because our rain dot test in clinic only measures to 20 seconds of arc, and this measures way farther than 20 seconds of arc. So here we're going to learn how to do it. So we're going to start measuring here with our 3 millimeter test plate, and we're going to measure our first distance of 25 centimeters from the observer. And we're going to do 10 trials here, so go ahead.
Top right.
Okay, close your eyes, and we're going to swap. And again.
Bottom left.
And we're going to continue to do this for 10 trials at each of the test distances for 25 centimeters to 400 centimeters. While doing the trials, we will go and mark correct, 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 and we will give them an X if they miss it for each of the 10 trials at each test distance. We'll do that for all test distances, 25 to 400 centimeters, and 10 times for each. We will mark the percent correct for each trial. Now, based on our graph, we know that the guessing rate based on our 4 alternative choice tests is at 25%, and that means that our threshold will be around 62.5%. This is what our psychometric function graph would theoretically look like for this data. We can use this equation here to change disparity into arc second based on our graph above. You would use this equation to use the PD of the observer in centimeters, the plate thickness in centimeters, which we used our 3 millimeter plate, and the distance in centimeters on the bottom here. You do this for the chance performance at 25% and also for the threshold performance, which we got to be 62.5%. So you do this for 2 different equations. For example, our first equation is using our 25% chance performance, and we just used a theoretical number of 327 centimeter test distance and plugged in our numbers and decided that this came out to be 2.33 arc seconds for our theoretical person here. And you would do the exact same thing for the threshold performance, but you would use the test distance that you would get for 62.5% instead of the 25%. And this would get you your arc seconds that came with your graph.